Welcome back. The previous session presented the concept of the optimum product quality goal, that goal which meets the needs of customer and supplier alike and minimizes their combined costs. In this session, the subject is methods to optimize product design.
Knowledge of customers' needs is often sufficient to enable you immediately to meet those needs with standardized goods and services. Many times, customers state needs specifically in terms of standardized products. Many other needs can be met if you have designed your processes to provide a range of products corresponding to the usual range of customer needs. However, there are many cases in which, despite your knowledge of customers' needs, you can't immediately meet them. Your processes may simply be unable to meet those needs. You may be able to meet the needs, but at a price that customers would be unwilling to pay. You may be able to meet the customer's real needs, but not the stated needs, or vice versa. Reconciling these incompatibilities requires a search for the optimum. From the standpoint of benefit to society, the optimum is clearly the ideal goal. Reaching that goal requires overcoming the traditional urge of customers and suppliers to sub-optimize, to meet their separate goals. In market-based societies, the dominant tradition has been for each company to look out for its own interests, to meet its own quality needs, and to minimize its own costs. Further, the demands of competition have inhibited companies from sharing proprietary information with supplier companies. The companies have been afraid that information leaks will result in loss of competitive advantage. This fear has in many cases blocked cooperation between companies toward optimized quality goals. Sub-optimization is also a widespread problem within companies. A major contributing cause is the practice of establishing departmental goals and then judging the performance of managers and employees based on departmental performance against those goals. This practice is inherently sound. People get more done when they do have goals and are judged by their performance against goals. However, it is all too easy for a department to improve its performance and in doing so damage company performance. A purchasing department reduced the cost of purchased materials by buying a year's supply rather than 1 month's supply at a time. However, the net result was a loss to the company. The material deteriorated gradually during storage. The effect over a month or two had been tolerable. Over a period of many months, it was not tolerable. Far too frequently, changes made by design or manufacturing departments to reduce the cost of making the product have resulted in increased company costs due to higher warranty and service charges. A major remedy for sub-optimization is joint planning. Such planning is already going on in many forms. Some service companies prepare and publish information to help customers analyze their needs. A widespread example has been in the area of energy conservation. Many electric utility companies offer a service of technical representatives to visit with customers, analyze their needs, and provide consulting assistance. In some instances, joint planning has resulted in an extensive shift of work between independent organizations. A major activity in the U.S. Postal Service is sorting the mail based on destination. Joint studies revealed that companies which send out large volumes of mail are in a position to pre-sort such mail faster and with less effort than the Postal Service. In turn, the Postal Service established a discounted price for pre-sorted mail. Joint planning, whether between companies or within companies, requires creating participation, securing needed inputs, and resolving differences. Let's look at each of these activities more closely. Finding the optimum quality goal involves balancing needs. Ideally, the search for an optimum should be done through the participation of suppliers and customers alike. Creating such participation requires creation of an atmosphere of mutual trust. In turn, this requires face-to-face meetings, mutual visits to see and understand operations, sharing of experiences and feedback, exchanging critiques and ideas.
Eastman Kodak, an aluminum company of America, have provided a trailblazing example of such participation and trust. The Davenport Works of Alcoa is a supplier of aluminum sheet to the Colorado division of Kodak. Kodak uses this sheet to make lithographic plates. For years, the two companies had conducted business on a friendly basis, but across the walls of secrecy which surrounded their respective proprietary processes. In 1983, out of a mutual determination to improve the quality of lithoplate, the two companies formed a joint quality team with access to the previously secret processes. In 1986, the joint team reported dramatic progress in their efforts. Rejection of aluminum sheet at Kodak was down by 80%. Alcoa had reduced rework by 43%. Lead times and inventories had been reduced. And the final customer experienced a significant improvement in on-time delivery. These results would never have been possible without an atmosphere of mutual trust. There's no written contract involved. The agreement to plan jointly is based on mutual recognition of a need to collaborate and on a handshake.
In some cases, there are logical reasons for restrictions on sharing information or on areas open to visits, even within the same company. For example, the formula for a well-known soft drink syrup is considered such an important company asset that it is kept in a bank vault, where access is limited to a few senior executives. Or again, some suppliers compete with their clients for sales in the same market. In any such case, the need is to make the restriction in the open rather than in secret, to make clear that it is a justified exception to the rule.
It takes more than an open environment to assure participation in goal setting. There is also a need to provide organizational machinery. Two common forms of organization for participation in goal setting are the coordinator and the interdepartmental or intercompany team. The coordinator may be a member of the same specialist department which plays the leading role in planning the product or process to which the goal is to apply. Alternatively, the coordinator may be a member of some department whose major role is coordination, for example, program management. Either way, the process of participation is essentially the same. The coordinator makes the rounds, visiting each customer to secure input. Based on this input, the coordinator prepares a proposal, which is sent to all customers for comment. The comments are then discussed, after which the proposal is revised and then published as a quality goal. The use of a departmental specialist as a coordinator has an obvious risk of bias. The specialist may resolve issues in ways which favor the specialist's departmental goals or avoid departmental blame. This risk can be reduced by providing clear policy guidelines, clear definition of responsibility, clear channels for upper management reviews. Use of a coordinating department reduces the inherent biases but increases the front-end costs. But these costs may earn a high return on investment in the form of fewer crises or shorter time cycles. The major alternative to the coordinator concept is the interdepartmental team. The team may be created for a specific limited purpose, an ad hoc planning team, such as your project team, or it may have a continuing existence, such as a design review team. A design review team is a piece of organizational machinery made up of specialists from customers who are impacted by the design. The team may include those who are to develop the operating process, produce the product, test the product, use the product, maintain the product. These specialists have no responsibility for design of the product. Their responsibility during the product development is to provide early warning to the designer.
What inputs do we need from this participation? What information can the various customers of our product or process offer to help us arrive at the optimum? All of them have experience and expertise to share. Participation provides early warning of upcoming problems. Information emerges in the form, if you design it this way or set this goal, here's the problem I will face. Participation enables the various customers to contribute data to aid in finding the optimum. These customers are frequently in a position to provide data in the form of costs which will be incurred, process capability of facilities, and so on. Such data are of obvious help for optimizing overall performance. Participation also stimulates challenge to theories. Specialist departments are typically masters of their own specialty, but seldom masters of the specialties of other departments. In the absence of participation by those other departments, the risk is that unproven theories or unwarranted beliefs will prevail. Participation by the customers provides an informed challenge. Collectively, such participation improves the chance of selecting optimal goals. In some cases, the major obstacle to reaching the optimum is lack of essential information. Usually, the missing information must be developed by combining and analyzing data from multiple departments. Examples of such analysis are competitive analysis. How does the performance of this product compare to competitors' products? Salability analysis. How do prospective buyers view the product? Life cycle costing. Does this design emphasize low selling price or low long-term cost of ownership? For those who have the responsibility to find the real optimum, it is tempting to make do with such information as is already available. You should resist this temptation. To find the optimum, you should first identify the essential information elements. What are the questions to which you need answers? Then you should determine whether this information is already available, and if not, whether it is worthwhile to create it. In special cases, we put differences aside and rely on the judgment of the acknowledged expert. When our planning requires preparation of a new form of product warranty, the wording of the warranty is critical. If poorly worded, the warranty may expose us to extensive costs in the form of unjustified claims. We rely on the lawyer's opinion as to how the wording would be interpreted by the courts. We do not look to the lawyer to determine what should be the features covered by the warranty or what should be the duration of the warranty. Those are business questions to be answered by the managers who collectively run the business.
Optimizing quality goals inevitably involves resolving differences. Managers and behavioral scientists have developed ways of resolving differences. Let's look at an example from each group. The Coonley-Agnew process for resolving differences was set out in a paper published by two industrial managers. It related to an attempt to establish national quality standards for cast iron pipe. The climate for agreement was decidedly unfavorable. The major parties to this negotiation were the manufacturers and the ultimate users, municipal governments. For years, they had distrusted each other. So when a joint committee was set up to develop the quality standards, the chairman stipulated three things. First, the parties must identify their areas of agreement and their areas of disagreement. That is, they must agree on the exact point at which the road began to fork. When this was done, it was found that a major point of disagreement concerned the validity of a certain formula. Second, they must agree on why they disagreed. They concluded that the known facts were inadequate to decide whether the formula was valid or not. Finally, they must decide what they are going to do about it. They decided to fund research to discover the facts. With the facts at hand, the controversies disappeared. From the side of the behavioral scientists, management philosopher Mary Parker Follett offered an analysis of resolving differences through dominance, compromise, and constructive conflict. These three methods are best explained with an example. When a customer buys a refrigerator, the design of the kitchen dictates a choice: a refrigerator with a door hinged on the left side or one that's hinged on the right. There was a time when, to accommodate this choice, manufacturers made two models, one left-hand and one right-hand. At one company, this caused a problem. While the sales department could make a reasonably accurate prediction of total refrigerator sales, it was unable to make an accurate prediction of the mix of left and right-handed models. This led to a conflict between the sales manager and the plant manager. The sales manager wanted adequate supplies of both models so that orders could be filled promptly. The plant manager, on the other hand, was unwilling to inflate total inventory to accommodate the uncertain demand for individual models. One way to resolve the conflict was for the plant manager, with longer service and more clout in the company, to use dominance. I'm not going to inventory one more refrigerator than is justified by total sales. If the model mix isn't right, that's too bad. The decision gets made, but the plant manager sub-optimizes at the expense of the sales department and the company. A second way to resolve the conflict was for the two managers to compromise, split the difference. The plant manager agrees to increase inventory of each model, but only by half of the number asked for by the sales manager. That's a less abrasive approach than the dominance, but neither manager is totally satisfied. The third way of resolving the conflict was through what Follett called constructive conflict. The sales manager and the plant manager dedicate themselves to inventing a solution which satisfies them both. They come up with the design we see in refrigerators today. There is just one style of door and one style of frame. The hinges and latch can be reversed to make the refrigerator door either right-handed or left-handed. And if necessary, the change may be made after the refrigerator has left the factory. Inventories may be cut with no loss of sales responsiveness. Constructive conflict embodies the spirit required for a team to arrive at optimum goals. Without that spirit, many opportunities to reach the optimum are lost. The process of optimizing concludes with a list of product goals for the various product features. The goals should be written out. This discipline helps to assure that the goals are understandable. The goals should be approved by the appropriate authority. This helps to assure their legitimacy. As you establish each product goal, enter it in the spreadsheet at the bottom of the corresponding column. The precision with which the goal is expressed reflects the level of detail of the product features. In the automobile heating system, the product features listed are the major components of the heating system. The goals reflect the goals for the entire heating system. The inlet restriction, the space to accommodate the heating system, must be adequate. The heater core must be able to deliver the heat output for which the system is designed, and with no leaks. The heater case and the ducts must allow the designed airflow, and the blower must move 200 cubic feet per minute of air and do it quietly. The engine coolant system must be full, or else the heater core will be starved and not work properly. These goals complete the product design spreadsheet. In the remaining sessions, you will be making use of additional related spreadsheets to aid in the final steps of quality planning.
The optimum quality goal is to meet the needs of customers and suppliers alike and minimize their combined costs. A major obstacle to reaching the optimum is sub-optimization. The major remedy for suboptimization is joint planning. Essential to joint planning are participation, securing inputs, and resolving differences. Participation may be organized through use of coordinators or interdepartmental teams. An important type of interdepartmental team is the design review team. Participation provides several kinds of input to goal setting: early warning of upcoming problems, data to aid in optimizing, challenge to theories. To resolve differences, it is advantageous to identify the specific decisions and actions which are at issue. The Coonley-Agnew process for resolving differences stipulates 3 conditions. First, the parties in the negotiation must identify their areas of agreement and their areas of disagreement, the exact point at which the road began to fork. Second, the parties must agree on why they disagree. And third, they must then decide what they're going to do about it. Follett's alternatives for resolving differences are dominance, compromise, and constructive conflict. Constructive conflict aims to invent a solution which satisfies the needs of both parties. In the next session, you will move from product-related quality planning steps to the subject of process development, designing the process to produce your product. See you then.